This is SpaceTime Series 21, Episode 55. Coming up on SpaceTime, the Dawn spacecraft reaches its lowest ever orbit around Ceres, the red planet Mars nearing opposition, and a new study shows there's enough space junk out there to build the Eiffel Tower. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
NASA's Dawn spacecraft has reached its lowest ever and final orbit around the dwarf planet Ceres, returning thousands of stunning new images and other data. Mission managers manoeuvred the spacecraft into an orbit that dives to just 35 kilometres above Ceres' surface. From this vantage point, scientists were able to observe the mysterious Auffel crater and its famous bright deposits and other intriguing regions. In more than 3 years of orbiting Ceres, Dawn's lowest altitude before now was more than 10 times higher at 385 kilometres. Consequently, the data gathered from this new orbit brings this ancient world into much sharper focus. These low orbits have revealed unprecedented details about the relationships between the bright and dark materials in the region of Venalia Facultae. Dawn's visible and imaging mapping spectrometer had previously found that the bright deposits in Auffel crater are made of sodium carbonate, a mineral commonly found in evaporite deposits on Earth. Last week, Dawn fired its ion engine possibly for the last time to fly nearer to Ceres Facula, a large deposit of sodium carbonate near the centre of Auffel crater. The massive amounts of information contained in these images, and those that are planned in coming weeks, will help address key questions about the origins of the faculae, the largest deposits of carbonates observed so far beyond Earth, and possibly Mars. In particular, scientists have been wondering how this mineral was exposed in the first place. Did it well up from a shallow subsurface reservoir of mineral-laden water? Or did it come from a deeper source of brines, liquid water enriched with salts, percolating upwards through fractures? And the new lower altitude observations being obtained by Dawn's other instruments, a gamma-ray and neutron detector and a visible and infrared mapping spectrometer, will reveal the composition of Ceres at finer scales, shedding new light on the origin of minerals found across Ceres' surface. New gravity measurements may also reveal new details about the Cerean subsurface. The Dawn spacecraft was launched back in September 2007 on a mission to explore the worlds of Vesta and Ceres, the two largest bodies in the main asteroid belt between Mars and Jupiter. These two worlds are on opposite sides of the snow line, the distance from the Sun where it's cold enough for volatile compounds such as water, ammonia, methane, carbon dioxide and carbon monoxide to condense into solid ice grains. The 1,218 kilogram spacecraft achieved orbit insertion around the asteroid Vesta in July 2011. Vesta is the brightest asteroid visible from Earth and contains some 9% of the total mass of the asteroid belt. The 525-kilometre wide world has a differentiated internal structure typical of terrestrial planets, with a metallic nickel-iron core surrounded by a rocky mantle. After 14 months of surveys, Dawn left Vesta and travelled to its second target, the dwarf planet Ceres, arriving in March 2015. Ceres has a diameter of 945 kilometres, making it the largest object in the main asteroid belt, containing a third of the total mass of the belt. Ceres appears to be differentiated into a rocky core and an icy mantle, and may have a remnant internal ocean of liquid water beneath its icy crust. Ceres' surface is a mixture of water ices and hydrated minerals such as carbonates and clays. You're listening to SpaceTime. I'm Stuart Gary. The red planet Mars is nearing opposition, the point in its orbit where it's on the direct opposite side of the Earth to the Sun. Opposition will occur on Friday, July the 27th. It happens every 2 years. The orbital mechanics of all this are quite fascinating. See, Mars and Earth orbit the Sun at different distances. The average Martian orbital distance from the Sun is 227.9 million kilometres. That compares to the Earth's average orbital distance from the Sun of just 149.6 million kilometres. So, by being further away from the Sun, Mars is on a longer orbit, taking 687 days to complete each Martian year. That compares to the Earth's 365 and a quarter days. This year's opposition is special because it coincides with Mars also reaching its closest orbital position in relation to the Earth since 2003, and that was its closest orbital approach in almost 60,000 years. This variation is caused by neither Mars nor the Earth orbiting the Sun in perfect circles, but rather in slightly elliptical orbits, which also change in orientation over time. The closest orbital approach to Earth will occur on Tuesday, July the 31st at 17:50 in the evening Australian Eastern Standard Time. That's 3:50 in the morning US Eastern Daylight Time and 7:50 in the morning Greenwich Mean Time. The average distance between Mars and the Earth is roughly 225 million kilometres. But that can stretch out to as much as 401 million kilometres when Mars is on the other side of the Sun to the Earth. However, during the 2003 close orbital encounter, Mars and Earth were separated from each other by just 55.8 million kilometres, a record which won't be broken again until August the 28th in the year 2287. During this year's close approach, Mars and Earth will be separated by just 57.6 million kilometres, a short walk in astronomical circles. Mars will also be in perihelion, its closest orbital position to the Sun during opposition. The combination of these three factors, opposition, close orbital approach to the Earth, and perihelion to the Sun, make this month's event a must-see spectacle for astronomers. With all the details, we're joined by Jonathan Nally, the editor of Australian Sky and Telescope magazine.
Well, Stuart, July 2018 at least means Mars, right? Now, we've spoken about Mars on the program. You've dealt with Mars before, and of course we all know that this is the time that we're going to see Mars, and we're going to see it really big. It's going to be the biggest big thing that we've ever seen, as a certain president would say. It's going to be really, really big, and we're going to win
big with Mars, okay?
Biggest since 2013, in fact.
It's the opposition of Mars in July. That comes up on July the 27th, actually. And don't get so caught up on that particular date. It's the day before, the day after, week before, week after. It doesn't really matter. All that opposition means is that, imagine looking down on the solar system. You've got the sun in the middle, and the planets are going around in their nice almost circles. And so you've got the Earth going around there, and then Mars is a bit further out, and it's going around as well. And the further out you go from the sun, the slower the planet's orbit. So the ones on the inside laps, they lap the outer ones. So every couple of years, the Earth laps Mars on the inside track, and you've got the sun, the Earth, and Mars all lined up in a line, so that the sun and Mars are on opposite sides of the sky as seen from Earth, and that's opposition, right? What that really means for us down here on the planet, the surface of this planet looking out into space, is that around opposition, that means when the sun is going down in the west, the planet is rising in the east, because they're on opposite sides, opposite directions in the sky. And as I say, it's not particularly dramatic that it has to be that night that you go out and have a look at it. You know, if it's cloudy, don't worry, look for the next night or next week or whatever. But around that time of opposition is good for any of those planets on the outer tracks. You've got Mars, Jupiter, Saturn, Uranus, Neptune, and Pluto, which I still call a planet. Let's not get into that again. It simply means that when
Stern would love you for that.
Yes, well, I still call it planet. I think I always will, but yes, I'm a heretic. Never mind. But basically means that when it's lined up like that, then it's more or less closest to you. That planet is closest to the Earth, more or less. The closest point and the opposition point are not necessarily the same day. They're very close, but not the same. And because it's closest to you at that point, it looks bigger than when it's further away. And in the case of Mars, this July, it's actually, for instance, a couple of months ago, between May and now in July, Mars appears to double in size. Right? That's how dramatic it can be. And with Mars being a very small planet, it's much smaller than the Earth, you want to get as much size as you can when you're looking through a telescope. And even through a telescope, it still looks pretty small compared to, say, Jupiter or Venus.
Well, when we look at the Earth from Mars, from one of the rovers, and we've got a few images like that, usually with the cliche, "you are here," arrow pointed towards it, the Earth just looks like a small solid star as well.
Yeah, to the naked eye, it just looks like a star. But if you look through a telescope, then you can certainly see the globe. You know, you can see an actual disk of the planet. So if you're here on Earth and you're looking at Mars, then it looks like a small reddish, orangey sort of planet, and you can make out some details. And the bigger your telescope, the better the view. But if you're on the other way, looking from Mars to Earth, Earth would appear to be much bigger to a Martian than Mars does to an Earthling. That's simply because Earth's a lot bigger than Mars.
So yeah, you want to try and get as much size out of planets as you can. So around about the time of opposition is the best time to see. And on the date of opposition, Mars is going to be 57.6 million kilometres away. That's one of the things I like about looking out into space, is actually finding out how far things are away, and that's when it really blows your mind. You think, wow, that thing I'm looking at there is 57.6 million kilometres away.
And there's a red Tesla heading there now.
There's a red Tesla heading out in that direction, that's right. Venus, the next planet in from us, the second planet from the Sun, that actually comes closer to the Earth than Mars does, you know. So this year...
And
Mars,
it's bigger as well, same size as the Earth, just about.
Yeah, Venus is about the same, so about the same size as Earth. So Mars is coming 57.6 million kilometres. The average distance that Venus comes to us on its closest approach is about 41 million kilometres. So you actually get Venus looks bigger through a telescope, but there's less to see because it's just covered in these white clouds, and you don't really see any detail at all.
Well, this time when we see Mars, it'll be covered in orange clouds, won't it, which will actually be dust.
Yeah, you often get dust clouds, and there seems to be one building up right now.
Big one right now, yeah. Opportunity's already been shut down for science experiments until the worst of the storm is over. And luckily, Curiosity doesn't use solar panels. It uses its own nuclear battery power source.
That's right. So that one's going to be fine. Let's hope the little solar-powered rover survives. Should do. It's been through it before. It's been there for quite a lot of years now.
Well, six of one, half a dozen of the other with both Spirit and Opportunity. Because one of the things that was happening during dust storms is, they were getting less power from the sun, but the wind was also dusting off the top of the solar panels, making them clean again. So it was a give and take thing.
That's right, because the dust was just slowly settling on top of the solar panels, reducing their effectiveness. And I think there was at least one occasion, wasn't there, with one of those little tornadoes, a little whirligig came past and helped clean off the panels. The thing with the Mars storms is that they can become ferocious in terms of speed. They can get very high winds on Mars, but the atmosphere is only 1/100th.
Yes, don't believe what you saw in the movie The Martian. It can't really happen.
No, that's right. It can be very fast, but doesn't have as much force as a storm here on Earth does because the air is so thin.
Yeah, 1/100th out of Earth's atmosphere at sea level.
Yeah, so you don't have to worry about that too much. But anyway, Stuart, so July is Mars month this year.
That's Jonathan Nally, editor of Australian Sky and Telescope magazine. I'm Stuart Gary. You're listening to SpaceTime. As of the end of 2017, it's been determined that there are at least 19,894 bits of space junk large enough to be detected by ground-based telescopes currently orbiting the Earth. The findings in the European Space Agency's annual Space Environment Report indicates the growing problem of observable space junk as a combined mass of over 8,135 tonnes. That's more mass than the entire metal structure of the Eiffel Tower. Space debris includes all man-made non-functioning objects in orbit around the Earth, some of which regularly re-enter Earth's atmosphere. The space age began 60 years ago, on October 4th, 1957, with the launch of the Russian satellite Sputnik, Earth's first artificial satellite. Ever since then, the amount of debris in orbit has steadily been increasing. Initially, this was due to discarded rocket upper stages and defunct satellites left to drift in orbit. But over the years, other stuffs joined this growing collection, including small bits generated by explosions, expended fuel, and even collisions. The latest ESA report on space debris not only looks at how the space environment's evolved in the past year, but also how it's changed since Earthlings first sent rockets and their satellite payloads into the heavens. These ghosts of past scientific and military endeavours continue to haunt Earth's environment. On occasion, some smash into each other in orbit, creating even more fragments which have the potential to do further damage to active missions. Eventually, some space debris will enter the atmosphere. And while smaller bits will burn up, larger pieces have the potential to crash down on the Earth's surface, potentially in populated areas. This year's report also shows the number of objects has increased. No surprises there. But there is some good news on the horizon. Most spacefaring nations are now including end-of-life programs in their rocket launches, ensuring that what goes up will eventually come down under a controlled manner. And for those bits that aren't coming down, the European Space Agency's Clean Space Initiative is now looking at ways of cleaning up the space environment. However, it's not made easy by decisions such as that of China a few years ago to use a disused weather satellite for target practice, blasting it to bits in the show of its military and technological prowess, but in the process leaving thousands to millions of bits of shrapnel, too small to be tracked, orbiting the planet in a deadly cloud threatening the safety of everything in its path. Scientists now hold real fears of a cascade event, where one bit of space junk travelling at 26,000 kilometres per hour slams into another spacecraft, destroying it, in the process causing its debris to collide with other spacecraft, which then collide with still others, and so on. Although widely condemned for their actions, Beijing has never apologised, never offered to clean up the mess, or even demonstrated that they have the technology to do so. You're listening to SpaceTime. I'm Stuart Gary. The research, development and production of cutting-edge astronomical instrumentation and technology developed by the Australian Astronomical Observatory will continue through a new consortium led by Sydney's Macquarie University. The move is all part of the breakup of the Australian Astronomical Observatory following Australia's decision to become part of the European Southern Observatory. Macquarie University has taken over as the lead institution in the new partnership, which also includes the University of Sydney, the Australian National University and Astronomy Australia Limited. The new consortium, to be known as AAO Macquarie, with the letters AAO this time standing for Australian Astronomical Optics, will carry on the 45 years of world-class research and optical instrumentation development and capabilities first established by the former Australian Astronomical Observatory. Over the past 45 years of operation, the AAO has developed and built over 40 precision astronomical instruments for some of the world's leading telescope facilities. They're currently designing and building a new fibre positioning system for the European Southern Observatory. The new technology uses optical fibres to track thousands of stars simultaneously for the most comprehensive survey of the Milky Way galaxy, as well as the large-scale universe ever undertaken. To find out more, Andrew Dunkley is speaking with Dr. Fred Watson from the Department of Science.
Well, okay, this could be difficult. Fred Watson, astronomer at large, because he's no longer part of the Australian Astronomical Observatory, because it doesn't exist anymore. Hello, Fred.
Good morning, Andrew. How are you?
I'm well and confused
Yeah.
about your potential future.
My future's looking okay, thanks to the fact that I'm now a member of staff. Well, I have been for the last 8 years, a member of staff of the Department of Industry, Innovation and Science, which was the parent government body that operated the Australian Astronomical Observatory. So I was in the AAO, the Astronomical Observatory was a division of the Department of Industry, Innovation and Science. But what's happened is that as part of a really big shake-up of optical astronomy or visible light astronomy in Australia, the Australian Astronomical Observatory has been essentially metamorphosed into two separate entities that now belong to the universities or are now operated by the universities. So our telescopes up in Coonabarabran, the United Kingdom Schmidt telescope and the Anglo-Australian telescope, the 3.9 metre, that's the biggest telescope of its kind in Australia, they are now operated by a consortium of 13 universities, but it's led by the ANU, the Australian National University, which actually operates the site, the Siding Spring Observatory site. So it's a very natural fit. So our staff up there, most of them have become staff members of the ANU. And it's quite interesting because the boss they're working for used to sit in the office next to me here in Sydney, a former member of the staff of the Australian Astronomical Observatory, and indeed the director of the Research School of Astronomy and Astrophysics at Mount Stromlo Observatory, part of the ANU, is a former director of the AAO. So it's a very small world. And everybody kind of knows each other. We know our strengths, we know our weaknesses, we know what buttons not to press and things like that. So our Siding Spring staff have become part of ANU. The staff in Sydney, and that's actually the bulk of the AAO staff members, because we build high-tech astronomical instruments here in Sydney, and the world wants those instruments, so that is also ongoing. They are becoming part of a consortium of universities, three of them actually, Sydney, ANU and Macquarie, and it will be managed by Macquarie University here in Sydney. And in fact, it'll probably still be called the AAO, but that will now stand for Australian Astronomical Optics, and it will be part of the Macquarie University. And just to give you the other side of the coin. What has prompted this reorganisation is a deal that the Australian government has done with the European Southern Observatory, 10-year strategic partnership, which will allow Australian astronomers to have access to some of the finest large telescopes in the world on one of the finest observing sites in the world, which they're all very happy about.
Well, I said I was confused. I'm now concussed.
It's a complicated thing, yeah. So the observatory has disappeared in terms of its name, but most of its functions are ongoing. I am, as we said at the beginning, I haven't gone with either of those universities, but I'm staying with our parent department as an astronomer to do outreach and communication and advice on astronomy issues in government.
So you are an astronomer with DIS, which in the modern urban vernacular is not a very positive way of describing it.
Well, that's right. Actually, there was one time when it looked as though we were going to be the Department of Jobs and Industry, which would have been dodgy, but that one didn't actually happen. So this is what we are, and it's good.
That's Dr. Fred Watson from the Department of Science speaking with Andrew Dunkley on our sister program, Space Nuts. And this is Space Time. I'm Stuart Gary. And time now to take another brief look at some of the other stories making news in science this week with a science report. Finding a vaccine to protect people from HIV, the human immunodeficiency virus, has been the holy grail of HIV/AIDS research for decades. Most attempts have failed because the virus is able to rapidly mutate, rendering most vaccines ineffective. But now a report in the Lancet Medical Journal claims US researchers have created a vaccine that has managed to get to at least the first step, with 400 healthy unaffected adults mounting an immune response to the vaccine and 67% protection against SHIV, a closely related HIV in monkeys. The vaccine contains components of multiple HIV strains, a so-called mosaic HIV vaccine. And so far at least, it's been able to induce strong immune responses. It's one of only 5 experimental vaccines to make it this far since the HIV/AIDS epidemic began back in the 1980s. But it remains to be seen whether the vaccine will make it past the next crucial step. That will involve it being given to 2,600 at-risk women in southern Africa to see if it can protect them from infection. Meanwhile, a report in the journal eLife claims scientists at the University of New South Wales and in the UK have discovered that the human immunodeficiency virus hijacks a small molecule in the host cell in order to help protect itself from being destroyed by the host's immune system. Yet another tiny clue in this massive, deadly puzzle. A global investigation has found that plastic foam manufacturers in China are deliberately pumping illegal ozone-destroying chlorofluorocarbons, or CFCs, into the atmosphere. Ozone is important because it helps protect life on Earth from deadly cancer caused by ultraviolet radiation. Since the Montreal Protocols were brought in, the atmospheric levels of CFCs have been steadily decreasing. However, recent studies have found the decline in one of those compounds, CFC11, trichlorofluoromethane, has stalled, with the decline slowing by about 50% since 2012. Worse still, a report in the journal Nature, which we covered last month, warned that levels of CFC11 have actually been increasing since 2012. A worldwide hunt conducted by the Environmental Investigation Agency in order to try and find out who's illegally producing it found the use of banned CFC11 to be rife in China's plastic foam industry. In fact, investigators found that at least 18 companies across China are deliberately using CFC11 despite knowing it's illegal. The Australian Navy has ordered 9 new Hunter-class frigates to replace their ageing fleet of Anzac-class warships. The Hunter-class will be based on the Royal Navy's new Type 26 frigates, optimised for anti-submarine warfare. The Royal Navy are currently building 9 of the new warships. The $35 billion contract for the Australian frigates will see BAE Systems build the 9,700-tonne vessels in Adelaide, with the first expected to enter service in the early 2020s. The announcement follows the recent commissioning of 2 new helicopter assault ships, the first of 3 new Hobart-class Aegis air warfare destroyers, and the awarding of contracts to build 12 new Barracuda-class submarines to replace the often troublesome Collins-class. New frigates will come equipped with M860 Seahawk helicopters optimised for anti-surface and anti-submarine warfare. A new study shows that Australians spend an average of 7 hours a day on tablets, smartphones and computers trawling through the internet. Not including apps, the most time per viewer was spent on Reddit, where most people stayed for about 15 minutes every day. 14.5 minutes daily was spent on the porn site X videos. Facebook was in third place, with most people spending an average of about 10.5 minutes there every day. These were followed by 10 minutes on real estate sites, just under 10 minutes on eBay's Australian site, followed by another 9.5 minutes checking out their international sites. An average of 9 minutes was spent on Tumblr, 8.5 minutes on YouTube, and almost as much time on Pornhub, with Amazon rounding out the top 10 with about 7.5 minutes daily per visit. The other big social media sites were Twitter with about 6 minutes 19 seconds every day, and Instagram with 5 minutes 44 seconds. As for the news sites, the most time was spent on the Bureau of Meteorology's website with 6 minutes 53 seconds, followed by news.com.au, where people would spend an average of 5 minutes 27 seconds daily. That was only just ahead of the Daily Mail news site, where people would spend an average of 5 minutes 26 seconds. The most time spent on the more, shall we say, left-of-centre news sites were the ABC with 4 minutes and 5 seconds, followed by the Sydney Morning Herald with 3 minutes 42 seconds, and The Guardian, where people spent an average of 3 minutes and 17 seconds. You're listening to SpaceTime. I'm Stuart Gary, and that's the show for now. You can subscribe and download SpaceTime as a free twice-weekly podcast through Apple Podcast iTunes, Stitcher, Bytes.com, Pocket Casts, SoundCloud, YouTube, Audio Boom, from spacetimewithstuartgary.com, or from your favourite podcast download provider. SpaceTime's also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C., and available around the world on TuneIn Radio. If you want more SpaceTime, check out our blog where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us on Twitter through @StuartGary, at Spacetime with Stuart Gary on Instagram, and on Facebook, just go to www.facebook.com/Spacetime with Stuart Gary. Spacetime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to Spacetime with Stuart Gary. This has been another quality podcast production from Bytes.com.